Hello and welcome to the channel Beyond the Curve, and today I'll be answering question number 8 of the 2024 May June FP1 paper. So this question is about proof by induction, and it says proof by induction that for n is a member of positive integers, fn equals 7 to the power n minus 1 plus 8 to the power 2n plus 1 is divisible by 57. So it's a divisibility proof which should be done from induction. So there are 4 steps to be done in the proof, which are basis, assumption, induction, and conclusion. So the first step, as I have mentioned, is basis. So let me write that down. Basis. Now basis is the step where we prove that the equation, whatever the equation that they've given, or anything that they have asked us to prove, we should prove it by substituting n equals 1. So we say basis when n equals 1. So f of 1 is equals to 7 to the power 1 minus 1 plus 8 to the power 2 times 1 plus 1. Now this is equals to 1 minus 1, 0, and 10 to the power 0 is 1, plus 8 to the power 2 times 1, 2, plus 1, 3, which is 512. Now f of 1 is equals to 513. And is this divisible by 57? Yes. If we take a 57 out, we have a 9 remaining. So we can say that when n is equals to 1, f of n equals to 7 to the power n minus 1 plus 8 to the power 2n plus 1 is divisible by 57. Alright, the next step is the assumption. This is where we assume that a given equation, in this case the fn, we have to assume that when n is equals to k, f of k is divisible by 57, that it is true. Okay, so we say when n is equals to k, f of k, I'll write that down. I think there's not enough space. Okay, when n is equals to k, f of k is equals to 7 to the power k minus 1 plus 8 to the power 2k plus 1 is divisible by 57. And then we're done with the second step. Right? Now we move on to the induction step. Now this is where we conclude our proof. So we say induction. I always love to mention the name of the step before actually doing them. So I say induction, and here we're going to deal with n equals k plus 1. What happens when n equals k plus 1? So there are two, or there's actually more than two ways of doing this, but I prefer doing it like this: f of k plus 1 minus f of k. This is how I do this question. I start by saying f of k plus 1 minus f of k, and so on, and I go on doing the steps, and I prove that when n is equals to k plus 1, the equation is divisible by 57. So now, when I say f of k plus 1, it means n is equals to k plus 1. So I substitute k plus 1 to n. That's going to be 7 k plus 1, and then we have a minus 1 plus 8 to the power 2 times k plus 1 plus 1. Now this is f of k plus 1 minus, now we write what f of k is, which we have already done in the previous step. So that is 7k minus 1 plus 8 to the power 2k plus 1. We can bring the like terms together, such as, before that we can simplify it. So we can say 7 to the power k, this simplifies to 7 to the power k, plus 8 to the power 2k plus 3, minus 7 to the power k minus 1, minus 8 to the power 2k plus 1. So I will bring 7 to the power k and minus 7 to the power k minus 1 together, and 8 to the power 2k plus 3 and 8 to the power 2k plus 1 together, like this. Now to make these two terms, similar, what I can do is take a 7 out of the first term. So that will give me 7 to the power k minus 1. Now 7 times 7 to the power k minus 1 will give us 7 to the power k. So I have taken a 7 outside, and then I can write minus 7 to the power k minus 1. Plus, I can do the same with the last two terms. I can take 8 to the power 2 outside of the third term. So that will give me 8 to the power 2k plus 1 minus 8 to the power 2k plus 1. I'll simplify, so I will get 6 times 7 to the power k minus 1 plus 8 squared is 64, minus 1 will give us 63 times 8 to the power 2k plus 1. Now, for us to prove that something is divisible by 57, we need to get an equation which would be a multiple of 57. So in this case, we can take this 63 and split it up in such a way where we would get something as 57 times some expression. It would be 8 to the power 2k plus 1, like 57 times 8 to the power 2k plus 1 plus something. So in this case, that would be 6 into 7 to the power k minus 1 plus 6 times 8 to the power 2k plus 1 plus 57 times 8 to the power 2k plus 1. So we can see 6 plus 57, that gives us 63. So we have split these two. We have split, this one into these two, and we can also see that the 6 is common here and here. So we can take a 6 outside and bring those two terms together. So I'll write that one as 6 times 7 to the power k minus 1 plus 8 to the power 2k plus 1 plus 57 times 8 to the power 2k plus 1. we can see we have a 7 to the power k minus 1 plus 8 to the power 2k plus 1, which is familiar because that is when n is equals to k, which is what we have written here. And that's the same thing as this. So instead of writing this whole expression, we can simply say 6 times f of k plus 57 times 8 to the power 2k plus 1. And then we can bring this minus f of k to the other side, which would be f of k plus 1 is equals to 1 f of k goes to the right side. That would give us 7 f of k plus 57 times 8 to the power 2k plus 1. Now we can see that which is blue. Okay, this expression here is divisible by 57, right, which is very obvious. But when it comes to this one, f of k is something that we have assumed to be divisible by 57. So anything that's divisible by 57, if it is multiplied by a certain numerical value, it's still divisible by 57. For example, if I say that 8 is divisible by 2, right, we get 4 as a remainder. And if I say 8 times 3, it's still divisible by 4 because 8 times 3 gives us 24, and 24 is divisible by 2. So regardless of the number it's being multiplied by, 7 times f of k is still divisible by 57 because f of k is assumed to be divisible by 57. It's assumed to be true, that the proof or the divisibility is true there. So therefore 7 times f of k is also divisible by 57. So if I have to put it in a simple way, I'll write the conclusion, right? Conclusion for this step, which is f of k is assumed to be divisible by 57. So 7 times f of k is also divisible yeah, by 57, and 57 times 8 to the power 2k plus 1 is divisible is divisible by 57. Right, so what have I written? F of k is assumed to be divisible by 57, so 7 times f of k is also divisible by 57, and 57 times 8 to the power 2k plus 1 is divisible by 57. Therefore, f of k plus 1 is divisible by 57. That's a small conclusion for the induction step, but we have to go on to the conclusion step, the main conclusion step of the entire proof. Now that would be, we say that f of k, oh sorry, we say f of n. Let's say f of n. F of n is divisible by 57 when n equals k. So it is also, when I say it, I mean f of n, right? So it is also divisible by 57 when n equals k plus 1. F of n is divisible by 57 when n equals 1, so it is divisible, no, there is no space, so it is divisible by 57 for all n which is a member of the positive integers. Now this is the conclusion, which is definitely going to give you 1 mark, right? That's an important step, so don't forget to write the conclusion once you're done with the proof. So I hope you've understood this proof. So let me just go through it one more time. So first step is basis. That's where you prove the equation is true when n is equals to 1, and then you have the assumption step where you where you assume that the equation is true when n is equals to k, and then you have the induction step where you prove that something is correct when n is equals to k plus 1 by doing some manipulations and substitutions, and definitely by using the assumption in the previous step, right? And then the final one is the conclusion, where you have to mention that something, or whichever that they have given in the question, basically in this case the equation, that it's true when n is equals to k, so it's definitely true when n is equals to k plus 1. And since it is true for n is equals to 1, it's always true for n is equals to any positive integers, right? So that's the end of this question. If you like this video, please like and subscribe the channel, and I'll see you soon.